Here we're going to work through some of the practice problems for this chapter. So if you'd like to see the associated document that I'm going to be working from, it's linked on the course module for the producer costs, or it's available in the files folder on Canvas. So for all of these problems, we're going to be working with a firm that I've called Fry Supply. So for Fry Supply here, they're going to have a constant, the same production function for most of our problems here, where its quantity is equal to 2 times capital times labor. The price of capital will be $100, and the price of labor will be $200, okay, per unit, right? So that could be per week, right, for labor and for capital. Question number 1 says that in the short run, Fry Supply's capital is constant at 5 units. And part A asks us to find how much is asking us to find the firm's demand for labor in terms of output. All right, so rather than solving for a specific value of labor, we're looking for the relationship between labor and quantity for the firm. So what we're going to start with is the firm's production function. Quantity is equal to 2 times K times L. And we're going to substitute for capital. So we'll have 2 times 5 times L. That gives us quantity equal to 10 times labor. We'll divide both sides by 10. So we get that labor is equal to output divided by 10, right? So that tells us that the firm values labor for every wants to hire 1 unit of labor for every 10 units of output that it produces. B asks us to use our demand for labor, the firm's demand for labor that we found in part A, to derive the firm's short run total cost equation in terms of output. So keep in mind, whenever we're talking about total cost, we're starting with the ISO cost equation for the firm. So total cost is equal to the rental price of capital times the amount used plus the wage times the amount of labor employed. So we're given the rent and the wage as part of our givens for this practice problem set. So the rental price of capital is $100. We're going to multiply that by the amount of capital used, and then add 200, the wage, times the amount of labor used. And again, we want this in terms of Q. So we know in the short run here, the short run's what we're dealing with, Fry Supply is using and has to use 5 units of capital. So we're going to substitute 5 for capital. And we know it's demand for labor in terms of output. So we can substitute for labor here. And again, we're just substituting what we found for part A. So we'll have 200 times quantity over 10. And then we'll simplify. So we'll have cost in the short run is equal to 500. Sorry, that should be 500 plus 200 divided by 10 gives us 20 plus 20 times output. And that is the firm's short run total costs in terms of quantity. Part C asks us to derive the firm's average total costs, average fixed costs, average variable costs, and marginal costs. Right? So remember that average total cost is just total cost divided by quantity. Our equation we found for part B is the firm's total cost equation. So we can just take that and divide it by Q. So we'll have 500 plus 20 times Q all over output. We can break this up. So it's 500 over Q plus 20 times Q over Q. In that second term, the output variables cancel out, and we're left with 500 over quantity is plus 20 is equal to average total costs. All right, so there's our answer for average total costs. Moving to average fixed costs, we know that that's fixed cost divided by output. Looking at our total cost equation from B, we can identify fixed costs by seeing which of the terms does not vary with output. So that's going to be our 500 term because it does not have a quantity variable modifying it. So fixed costs we know are 500. Then we're just going to divide that by Q, and that gets us our average fixed cost. So average fixed costs are 500 divided by output. Average variable costs are variable costs divided by output, so variable costs over quantity. Our second term in our short run total cost equation is variable cost, right? We know because it's modified by quantity, it depends on quantity. When quantity is 0, 20 times Q goes to 0. So we know that that is our variable cost. So 20 times Q divided by Q, the quantities cancel, and we get that average variable cost is constant at 20. Finally, we have marginal cost, which is the derivative of total cost with respect to output. So we're going to take our total cost equation and find the derivative. So 500 has no quantity variable modifying it, so that's derivative is 0. And we're going to add to that the derivative of 20 times quantity. Q has a 1 exponent, so we'll have 20 times 1. And then 1 subtracted from the exponent on quantity is going to give us quantity to the 0 exponent, which any base raised to the 0 exponent goes to 1. So we're left with, again, 20 times 1, which is just 20. So we have that the firm's marginal costs in the short run are constant at 20. All right, so in this case, this happens sometimes, but not always. We have average variable costs and marginal costs being the same in the short run. So that is part C. Moving on to D. D asks what Fry Supply's short run total costs are when output is 100. So in that case, we're going to use our short run total cost equation but from before. So we'll have 500 plus 20 times output. We want to know what its costs are when output is 100. So we're going to substitute 100 for quantity. So we get 500 plus 20 times 100. That gives us 500 plus 2,000, which gives us $2,500 for our total costs. And that is our answer. Moving on to E, now we are asked to evaluate Fry Supply's short run average total costs, average fixed costs, average variable costs, and marginal costs when quantity equals 100. So we found previously that Fry Supply's average total costs in the short run were equal to 500 over quantity plus 20, right? This was from part C. So we're just going to substitute 100 for quantity. So that gives us 500 over 100 plus 20. 500 divided by 100 gives us 5. So we have 5 plus 20. So average total costs in the short run are 25. Average fixed costs we had at 500 over Q. So substituting 100 for Q, we get 100 over 500. That's going to leave us with 5. And then average variable costs we found were constant at 20. So it doesn't matter how much the firm is producing, they're always going to be 20. And then the same thing for marginal costs, right? They're constant at 20. So regardless of how much the firm is producing, those marginal costs are constant. Now we're going to move on to number 2, where we're looking at the long run. So now in the long run, both capital and labor can vary. So for part A, now we want to know what Fry Supply's demand for each input, capital and labor, is in terms of Q in the long run. So we have to solve for Fry Supply's cost minimization, right? So we need to find where its ISO cost curve is tangent to its ISO quant curve. So we're given the wage and rent, right? So remember that the wage is $200, the rent is $100. So we just need to find the firm's marginal product of labor and marginal product of capital. Recall that Bry Supply's production function is equal to quantity equal to 2 times K times labor times L. Marginal product of labor finding marginal product of labor requires us to take the partial derivative of output with respect to labor. And we're going to use the power rule. So labor has a one variable on it. So we're going to multiply the constants modifying labor, 2 and K, by 1. So we'll get 2 times K. We're going to subtract 1 from that exponent on labor. So we have labor to the 0 power, which goes to 1. So the marginal product of capital we find is just 2 times K. Doing the same for the marginal product of labor is just equal to 2 times K. Turning to the marginal product of capital, we get that the quantity that's going to be the partial derivative of quantity, with respect to capital. So we're looking at how output changes when only capital changes. Now we're treating 2 and L as our constants, and we're going to see how variation in K impacts the productivity output overall. So we'll have that exponent on capital is also 1. So we'll have 1 times 2 times L, because those are both the constants modifying capital. We're going to subtract 1 from that exponent on capital. So we'll have capital to the 0 power. Anything to the 0 power is 1. So we're just left with marginal product of capital equal to 2 times labor. So we're going to substitute for those values in our optimization problem. So we'll have 2 times K over 2 times L equal to 200 over 100. And from here, we're going to simplify. So on our left-hand side, 2 over 2 cancels out to 1, and 200 divided by 100 cancels out such that we're left with 2. So we have capital over labor equal to 2. We're going to multiply both sides by labor, so we get capital is equal to 2 times L. So twice as much capital will be used as labor. And that makes sense when we consider the prices of each. Labor costs twice as much as capital. From here, we're going to substitute for capital in the firm's production function. So we'll have quantity equal to 2 times capital, which we just said is equal to 2 times L, times labor. That's going to give us quantity equal to 4 times labor squared. And from here, we're going to solve for labor, because we want to know how the firm's level of output impacts how much labor it demands. Okay, so we're going to start by dividing both sides by 4. So we'll have quantity over 4 equal to this labor squared. Then we're going to take the square root of both sides. So we'll have quantity to the 1/2 power over 2 equal to labor. And that is the firm's demand for labor. Now we need to find the same in terms of capital. Luckily, we have this equation equating labor and capital, so we can just substitute for labor in terms of output what we just found. So that's going to produce for us capital is equal to 2 times quantity to the 1/2 power all over 2. So our 2's cancel out, they go to 1, and we're left with capital is equal to quantity to the 1/2 power. Right? So that is the firm's demand for capital. And that is our answer for 2A. Moving on to B, now we're asked to find the firm's total cost in the long run. So again, we're going to use our isocost equation from before. We're going to substitute for rent, which is 100. So we'll have 100 times capital plus the wage, which was 200 times labor. And we're going to take the firm's demand for labor and firm's demand for capital, which we previously found in part A, and substitute for capital and labor respectively. So we'll get total costs in the long run are equal to 100 times the square root of quantity plus 200 times the square root of quantity divided by 2. Right? Simplifying, we're going to get total costs in the long run is equal to 100 times the square root of Q plus 200 divided by 2 gives us 100 times quantity to the 1/2 power. We can add these, they're exactly the same. So 100 times the square root of quantity plus 100 times the square root of quantity gives us 200 times the square root of quantity. And that is our final answer. One thing I want you to note here is that in the long run, we only have total cost depending on output. So in the long run, we have no fixed costs, right? All costs are variable costs in this case. For part C, we want to find the firm's average total cost in the long run, as well as their marginal cost in the long run. Excuse me. We're not going to find average fixed costs because there are no fixed costs in the long run. And similarly, we're not going to find all average variable costs because all costs are variable costs in the long run. Okay. So to find average total cost, we're going to divide total cost by output. So we'll have 200 divided by quantity, 200 times quantity to the 1/2 power, all over output. So because we have quantity in the denominator and in the numerator, we can use the properties of fractions, and we're going to subtract the exponent on quantity in the numerator from that of quantity in the, we're going to subtract the exponent of quantity in the denominator from that in the numerator. So we'll have 200 times quantity to the 1/2 power minus 1, and that's going to give us 200 times quantity to the negative 1/2 power, which will be our average total cost in the long run. Okay. For marginal cost, we're going to take the derivative of total cost with respect to output. So again, referring to the total cost equation we found in part B, we're going to use the power rule. So we'll have 1/2. We're going to multiply that by the constant modifying output, which is 200. And then we'll subtract 1 from the exponent on quantity. So we'll have 100 times quantity to the negative 1/2 power, and that will be the firm's marginal cost in the long run. All right, so notice here, we have a very unique example where for marginal cost, quantity is actually in the denominator. So for part D, when it asks what happens to Frye Supply's long run marginal cost as quantity increases, in fact, we have here where marginal costs are always decreasing, they never go back up. So what we're going to see is a firm that has increasing returns to scale and is likely to grow infinitely large as a result. So as quantity increases, marginal cost decreases, and it never goes up. Part E asks us to find the firm's total cost in the long run when quantity is equal to 100. So we know that the firm's total costs are equal to 200 times quantity to the 1/2 power. So we'll have 200 times 100 to the 1/2 power, so the square root of 100, which is 10. So we're going to have total costs equal to 2,000. Part F asks us to evaluate the firm's average total cost in the long run and marginal cost in the long run when quantity is 100. So we're going to use that average total cost equation. So we have 200 times quantity to the negative 1/2 power. We can rewrite this as 200 over quantity to the positive 1/2. Substituting for quantity, we'll have 200 over 100 to the square root. That's going to give us 200 over 10, which leaves us with 20. So the firm's average total costs in the long run are constant at 20 when output is 100. For marginal costs, we know that the firm's marginal costs are equal to 100 times output to the negative 1/2 power. We can rewrite this as 100 over quantity to the 1/2 power. Substituting for 100 for Q, we'll get 100 over the square root of 100. That'll give us 100 over 10, which is equal to 10. So that's our answer there. We're going to end this part of the practice problems here, and then in the next video, go over questions 3, 4, and 5.